Here we go. Let's begin 7.3, multiplying and dividing rational expressions. Um, Pretty much as it says, that's what we're going to do. Some of the things that you got to remember when we are multiplying and dividing rational expressions is to make sure you simplify things all the way through. Another key thing right here is in our denominator, we got to remember we cannot have our variables end up equaling zero, because whenever we divide and we have zero in the denominator, that means it's undefined. So those are things to look out for as we begin this section. Let's take a look at these core concepts. The first one right here, simplifying rational expressions. So, if we have, it says let A, B, and C be expressions where B and C cannot equal zero. And pretty much, look, if we have same numbers uh, or we have same variables on the both numerator and denominator, what you see here is that we can go ahead and just cancel them out, and then we're left with A over B. Okay, so uh, one of the things that you've done ever since elementary school has been reducing. Well, what is it that happens when you reduce? You're pretty much taking out numbers that they both share, right? So like with 15 over 65 right here in the example, well, hopefully hey, both top and bottom, I could divide by 5, and then therefore that's how you could reduce things down. And so that's the same idea in concept as when we are reducing our rational expressions. Right here, once again, we talked about rational expressions in 7.2, or mentioned it again, is that there are fractions that are involved um, with variables in the denominator. And you'll see that right here once again. But rational, fractions, ratio, okay? And so right here, you can see in this second one right here, example, we always want to try to factor out as much as we can. And once we factor things out, that's when we can go ahead and start cross-canceling or reducing or doing all that stuff to get our final answer. Multiplying rational expressions right here. We could multiply things together. When it's multiplying fractions, you multiply straight across. And that's what that's what you see right here in the property, okay? Multiply straight across when it comes to multiplying fractions. Sometimes before you multiply, you can maybe cross cancel, and then that'll save you some trouble. But if they do ask, if the goal right here is to multiply by condensing, then that's what you're going to need to do. If you take a look at the example right here, though, they multiply straight across first when you took a look at the problem, which is right here. However, instead of multiplying everything straight across, you might be able to just start by cross-canceling things, and then you'll still result in the same answer of 3x squared over 2. Now, there's a few key things right here that you got to pay close attention to. Okay, the biggest part that's new to you guys will be writing down these restrictions. Okay, you have to write that x cannot equal 0 and y cannot equal 0. Okay, and so here's when you put these restrictions down. Okay, I'll go ahead and highlight it, but I have it already typed out, is that you write down restrictions when a solution is restricted in the original expression, but not in the simplified expression. If both original and simplified expressions have the same restriction, you do not need to write the restrictions down. Okay, so this right here is absolutely key, okay, to being able to do well in this section. So what does that mean? Okay, if we take a look at the original expression right here, I've got x and y. Okay, now remember, in the very beginning, what I told you was that, hey, look, I cannot have those variables equal to 0, because if it is, it's undefined. Well, look, it's there in the beginning, but when I take a look right here at the final answer, it's not there. All I have is 2. Okay, so I'm looking at the final answer right here, and the 3x squared over 2. There's no x, there's no y. So that's what I mean right here. It says that the solution is restricted in the original expression. So in the original, we have x and y squared, but it's not there in the simplified expression. So because it's not there, we don't know whether or not we have a variable, okay? And so that's why we have to put down x cannot equal 0, y cannot equal 0. All right. Let's go to the next part, rationalizing, dividing rational expressions. And so right here, we're going to take a look. And one of the key things is whenever you divide fractions, you multiply by the reciprocal. And so right here, I put down, hey, multiply by the reciprocal. So if we start off, the property, it shows that A over B is divided by C over D. What you have to do right here is take that C over D and then change it, or take the reciprocal of it, and then you can multiply the two together. All right, and there you go. We take a look at the example right here. Now, a few things to keep in mind when it comes to the restriction, okay? So we have 7 over x plus 1 and divided by x plus 2 over 2x minus 3, okay? So, in the original, restrictions that I'll have is this right here, the x plus 1, the 2x minus 3, and then we also need to kick in right here this x plus 2. So initial restrictions that I'll have is x cannot equal negative 1, okay? So right here, x cannot equal negative 1, x cannot equal right here 3 over 2, and that's when you take 2x minus 3, set it equal to 0, and then you get 3 over 2. The other one right here that we need to also keep in mind is x cannot equal negative 2, because when I multiply by the reciprocal, it ends up being in the denominator. So we have 3 different restrictions. Now, let's go ahead, and simplify things out, and we see what's here, okay? So, there's one restriction that was listed. It's x cannot equal 3 over 2, okay? Why? Because look, 2x minus 3 was once in the denominator. In the final answer, it's up here in the numerator. So you may not know, or you will forget the fact that it's a restriction. And so that's why you need to make sure you include x cannot equal 3 over 2 in your final answer. Well, why don't I, and so now it comes to the next part. Why am I not adding x equal to negative 1? Or x is equal to negative 2? The reason being is because I should already know, because it's in the denominator, that those are restrictions. So because it's already there, I do not have to include that in my final answer, because it's already embedded. They're expecting you to actually understand that and realize that now as we are in this part of the section, all right, or at this part in your Algebra 2 knowledge and journey. All right, so let's go ahead. Let's take care of business right here. Let's go ahead and take a look right here at number 1. We've got 2x minus 3, or 2x to the third power minus 8x squared divided by 6x squared. Simplify the expression if possible. Well, as is, there's not much you can do. But let's see, can I factor out anything in the numerator? And you certainly can. I could factor out a 2x squared, and I'm left with x minus 4. And then we have this over 6x squared. So, things that have been factored out, we can now go ahead and use that to reduce. I can see right here, the x squares can cancel. The 2 over 6 ends up becoming 1 over 3. So my final answer right here is going to be x minus 4 over 3. If we were to talk about our restrictions right here, if you look in the original, hey, there is an x. In the final answer, there is no x. So right here, let's go ahead and put x cannot equal 0 would be a restriction. Quite often what I see here and why students miss these problems is the fact that they look at the denominator and they look at like this 2x to the third and they're saying, I could reduce that down. Yes, you can. However, with what we're doing here, remember that 6x squared is being divided into both parts of the numerator. So you can't, if you're going to do take the 2x squared and divide by 6x squared, you also need to remember to divide the negative 8x squared over 6x squared. If you do both, then you're fine. But if you only do the part that I have highlighted in yellow, then you're going to get the answer correct. Okay? So that right there, important. Let's go ahead and take a look next up at number 3. Okay, so one thing right here that we talked about where we looked at the first section, or problem number 1, see if you could take out a GCF and start reducing things down. All right, so with number 3, in this problem right here, what do? Well, I've got trinomials, and with trinomials, you should be able to factor them. Okay, there's a good chance you could factor things out. And so if you weren't a pro at factoring or forgot some of that, well, you better go back and review that. For our numerator, remember, what are factors of 4 that add up to negative 5? Okay, so we got to be able to factor that out. If you forgot what all that stuff is, you can go back earlier in the school year and go over, we'll review that there. So right here, I factored out the numerator. Let's go ahead in my denominator. I could factor things out. And then I've got factors of 1 that add up to negative 2. We got x minus 1 and x minus 1. Okay? So we can go ahead and simplify a few things and we'll take that out. And so what I'm left with now is x minus 4 over x minus 1. Okay? And there you go. There is your answer. No restrictions. Why? Because look, in my denominator right here, my restriction would be x cannot equal 1. Well, yes, I got rid of one of the x minus 1s, but the other one is still there. So you should already know that based off of our denominator, that restriction of x cannot equal 1 is still applies, and therefore you do not have to put that down. Okay? Let's take a look at number 4. Try to give you as many examples as possible right here. So let's see. In my numerator, there's something you could factor out. I'll go ahead and factor out an x squared, and we're left with x plus 3. In our denominator, as we go through that, hopefully you realize that that's factorable right there. Factors of negative 24 that add up to negative 5. We have x minus 8 and x plus 3. Okay? Looks like the x plus 3's cancel out, and I'm now left with x squared over x minus 8. All right? There's my answer. Almost. Remember, in the beginning, we have the x plus 3 as part of my denominator, and that's a restriction. I don't have that anymore in my final answer. So we have to right here include that x cannot equal negative 3. Okay, so both of these must be there in your answer. And you're saying, where do you get that negative 3? Well, take the x plus 3, set it equal to 0, and x equals negative 3. If you plug that negative 3 into the equation, you'll notice that you get a 0 there. And once again, 0 is no good because of the fact of the matter that you will end up with no solution. All right? moving on. Let's take a look at number 5. We are multiplying, okay? Finding the product right here. So you can multiply straight across, but what might be easier is if you take a look and start cross-canceling or reducing before you multiply straight across. So when we take a look at number 5 right here, go ahead and zoom things in. I could look right above in the fraction and see what can I cancel out. I could cancel out that x, and then I could also cross cancel, and so this y and y squared can go away. There's nothing more I could cross cancel, so let me go ahead. I'll put my answer as 3y over 2xy. And there you go. We have now simplified things out. Or did we? We could actually still cancel out the y's, actually. And so 3 over 2x. Hopefully you see something. We have some restrictions. What is it? I'll give you a moment to think about it. And that right here is going to be y cannot equal 0. So make sure you have all of that stuff down right here. Okay? Let's take a look next up at number 6. So we'll start with the basics right here. All right, in this problem, we can go ahead and you cannot cross cancel first. Okay, that you cannot do when we're dividing. When we're dividing, let's go ahead, I'll rewrite this. We multiply by the reciprocal, so this is going to be y over 4x. Now, let's think about some things right here to begin with. It's possible that if the y's cancel out, then you're going to have to make sure you include that in the as a restriction. Okay? So remember, y was initially in the denominator right here. Okay? And now it's in the numerator. So I got to, once again, kind of keep that in mind, that if that y cancels out, then I have to put that as a restriction. And let's see what happens here. So looks like I could cross cancel this y, and that's good. And that is it. Okay, I can't cross cancel the 4x and the x plus y because the x is attached to the y. So let's simplify this out, and I've got x plus y over, and then you got 7x times 4x. I got 28x squared. Okay, and so that right there looks like my answer. Except, remember what I gave that little disclaimer in the beginning. If now we don't have y in the denominator anymore, and so I must also include the fact that y cannot equal 0. And now I have my answer. All right, so there we go with that. Next up, taking a look at number 7. All right, a lot of business, a lot of action right here. We'll go ahead, we'll rewrite some things out because when we are dividing, we are multiplying by the reciprocal. And so now when I go ahead and rewrite this, I've got x minus 6 on top, x minus 9 is on the numerator, and we got x plus 1, and then x minus 6. So don't forget, think about what do we have right now in our denominator that may not be there when we multiply by the reciprocal and simplify. Okay? So that'll kind of, I highlighted that so we can come back to that later. Let's go ahead and start cross canceling. X plus 1. Okay, we can go ahead and cancel that out. Let's see, anything else right here? Looks like there isn't a whole lot more. Except right here with our numerator and denominator, that x minus 6 can go away. Okay? So we have that. And then don't forget, we also want to think about our numerator over here as well. because remember, when we multiply by the reciprocal, now that becomes in the denominator. And so we'll end up having issues when we do multiply by the reciprocal. So let's go ahead now that we did that. I can go ahead and start combining things together. Um, in this section, unless they ask you to condense everything, let's go ahead and leave everything factored out. Okay. And that right there, x times x minus 9 over x minus 2 is your answer. But think about, we have some restrictions here. Okay. Look at some of the numbers that I highlighted, or the binomials. What was once in the denominator and numerator is no longer there. For example, the x minus 6. So that tells me x cannot equal 6. It was once in the original, but not in the final answer. The x plus 1 was in the original, but not in the final answer. So that means x cannot equal negative 1. All right. And then also that, remember, in the denominator we have x minus 9, but now it's in the numerator. So we must also say that x cannot equal 9. All right. And so there you have it. We have a bunch of restrictions, and we now have our final answer. All right. Exciting times, right? So if you're thinking, well, where does it get harder? Well, let's take a look at number 8. There's a lot of things going on right here. A lot of different type of factoring. In like 7, a lot of stuff has been factored out for you. Not in number 8. So luckily, in number 8, it's not dividing, so you don't have to rewrite a bunch of stuff. But I'll go ahead and rewrite each and every section down below. X squared minus 2x minus 3, factorable. X minus 3, x plus 1. X squared minus 1, one of our special factors. Remember, dose, difference of two squares. X plus 1, x minus 1. X squared minus 2x minus 63, factorable. X minus 9, x minus 7. Remember that 9 and 7 gets me 63. And actually, this needs to be x plus 7. Because negative 9 times negative 7, negative 63. Negative 9 plus 7 equals negative 2, your B term. All right, and then finally, the last one right here, we've got ourselves x, let's see, minus, or actually this time it's going to be x plus 7, x minus 3. All right, so a lot of things to look at. Keep in mind right here, our denominators, okay? There's a lot of stuff there, and the reason why is because, remember, if it's not there in the final answer, it's going to be a restriction. I don't have to worry about the numerators because this is not a division problem. So now let's go ahead and see what we could cross cancel. The x minus 3's, bye-bye. The x plus 1's, see you later. The x plus 7's, sayonara. And all of this now just becomes x minus 9 over x minus 1. We're almost there. Remember, at this point in time, we've got to take a look at our restrictions and some stuff that's in the denominator in the beginning that's not there anymore, at x plus 1. So x cannot be negative 1. That's one restriction. We have also right here, let's see, the 3. Okay, so x cannot equal 3. And then x cannot equal negative 7. All of those right here were in our denominator, but it is no longer there in our final answer. So all of this, make sure you include that in your final answer. All right. On number 10, you do the same thing, except you have to make sure multiply by the reciprocal. Okay, so if you're when we're to do number 10, it's exactly the same, but you got to multiply by the reciprocal first. I think I could save you the heartache on that one. Last one, let's take a look at number 9 then. Let's do this one real quick. You could see what we could factor out. I could factor out an x. So I got x minus 2. The x plus 7 stays there. In our numerator, we've got ourselves, this one right here is another special factor, the sum of two cubes. And so remember, this is going to be x plus, or if I could take the cube root of the first term, which is x, the cube root of the second term, which is 2, go ahead and we have a plus b is equal to a squared, so x squared, and then it's going to be minus ab, so minus 2 times x, and then it's going to be plus b squared, so we have 4 right there, and that factored out. We have, if you need to look this up, we have sum and difference of 2 cubes. All right, so that is that part right there that you might need to look up. A lot of, once again, a lot of action right here in this problem. And then so finally with our denominator, looks like I could factor out an x, and now I have x squared minus 4. And there's more action to come right there, because that x squared minus 4 is a difference of 2 squares. So let me go ahead right here. I will delete that and turn that into x plus 2 and then x minus 2. Maybe there's more that we could factor out. Is there? That x squared minus 2x plus 4, not factorable. Okay, so we've got no business with that. Can leave that alone. All right, so let's see what we have in our denominators right here. Okay, I'll go ahead and highlight that stuff. And let's see what we could start canceling out. This x, bye-bye. X minus 2, see you later. The x plus 2's, adios. So a lot of stuff in my denominator is no longer there. So when I go ahead and put my answer down, we have x squared minus 2x plus 4 all over x plus 7. All right, so lastly, let's put our restrictions down, and x cannot equal positive 2, negative 2, and 0. Once again, if you were to take each of those terms right there in the denominator and set it equal to 0, you will get these 3 numbers. And there you go, we've now finished and got our answer. Okay, so real important, make sure you have the restrictions down. Okay, the restrictions are critical. If they're not there in the beginning, or if they are in the beginning, they're not there at the end, then you got to mark the restrictions. There's a little bit extra steps that you need to focus on, especially when we're dividing and having the restrictions, because of the reciprocal. So if you go back to those questions, if you weren't sure of what are the restrictions there, all right? But once you just, you learn to just kind of calm down and, not rush through them, you'll realize, hey, the restrictions part is easy, all right? There you go, section 7.3.